Hi everyone, we're going to go through HTML forms as well as submitting a form to the server and computing results on the client side as well. So this week we're going to get into JavaScript on the front end as well, so it's a pretty exciting week. And we're also going to be showing the same code being run on the server side, or comparable code, because as we know, or as we're about to find out, you have to take on different strategies while working in the server side and working in client-side JavaScript. We'll also talk a little bit about some of the differences when you're running in server-side and client-side JavaScript. So, if you load up the code for this week, you'll notice that any page that's not calculator/static or calculator/server will just automatically route to the static page. If you can see here, that's just because of how we set up the route file. In the route file, if something's not picked up by our calculator routes, we're just going to redirect it to calculator/static. So just a nifty little trick right there. So the first thing you should know, let's open up calculator.js. Now here we only have 3 routes for this whole lecture. We have router.get/static, which is mounted on calculator/static. We're going to render the template for calculator/static. The model is going to be totally empty. Same thing's going to happen when we do route.get/server. It's going to run to the calculator server file, a handlebars file, with an empty model as well. What you'll also notice is we have a post route for /server. Notice these are named the same things, where we do some basic logical stuff, and then we render responses to calculator/server, but now we actually provide models as well. So it might be helpful to take a quick look first at the HTML we've got going on. Now, as you remember, we drop into a main layout and handlebars. So all this is going in this section. So in server, we'll start off with static, which is, we'll start off with server. So let me navigate to server. As you notice, it's basically the same code. Now, as you'll notice here, we have a very simple form with some just basic HTML. You'll notice that the form has to have something called a method. Now, a method dictates whether the browser sends the form over GET or POST. Now, if it sends it via GET, it throws the data into query string parameters. So if you were to be posting a username and password over GET, you'd have your parameters in plain sight if anybody's looking over your shoulder. POST will send it in the HTTP body, which the user will never be able to see from a URL, but they'll be able to. You'd be susceptible to things like man-in-the-middle attacks and people sniffing your packets, but that's why we use HTTPS. Now, every form has multiple inputs. Now, a form can technically have no inputs, just would post an empty body to a new page, whatever is set as your action. Now, you'll notice here we don't provide an action. That's by design. We are only posting to ourselves without an action. It posts to the same exact page you're on. Just a little trick right there. Now we have many inputs, and inputs, if you go through the slides and research on the MDN links provided, you'll see that there's many different types of inputs. But in our case, the only inputs we're going to use are 2 number inputs and 1 select input. Now, select is not an input tag, but it's a form of HTML input. All these inputs just act as a location for a user to interact with the web page. Now you'll notice here that every input has an associated label. Where there's a label for, then it has the same text as an ID. This can only link to an ID, or some browsers support linking to a name through the for attribute. So we have this label for number 1. We have a corresponding element with an ID of number 1. So when you click on that first number label, it automatically pops you into this first number input. The same with operation, and the same with second number. So, well, operation actually looks like there's a typo there. Fix that. There we go. Yep. Alright. So anyways, now ID equals operation. Refresh that page. And there you have it. You click on it, it selects that. Now these are very important from a standpoint of what's called accessibility, which we'll get into in one more lecture, as I recall. We'll be tackling accessibility, but what you have to know is that a label allows screen readers and other assistive technologies to point to an input much more easily. So when a form is properly labeled, it will be much easier for the users with accessibility impairments to be able to interact with your web page. Also, it allows scrapers and so on and so forth to more easily understand your web page. So the two inputs we have here are both numerical inputs. So as you notice, if I try and submit it, Firefox will automatically block it because LKJ, LKJL is not exactly a number. However, 9 is a number, so it allows us to submit. There's a pesky little breakpoint. And you'll see that we got an error back when we submit it. And I'll walk you through the route file momentarily. You'll see that when I add a second number, let's say 89, it gives us a result. We can do subtraction, we can do multiplication, we can do division. Yeah. Notice that when we do division, if we do 0, we get another error message, and so on and so forth. Alright, so you might be wondering how we do all this. And the answer is we set up a quick data module in which you could quickly glance through this. It's nothing major. It's just add, subtract, multiply, and divide with some basic error checking. It's not promise-based, so we're throwing in this data module. Now in our route file, you'll notice I'm going to put this breakpoint back, and we're going to post back here. And I'm not going to provide a second number, so I'm going to do addition. If you see here, let's take a look at our watch window. You'll notice that our operation is add, and you'll notice that in our request.body, these two, number 1 and number 2, show up as strings. Now, by default, everything that's posted that's not posted via JSON, which happens when we post AJAX requests, which we'll get into in a few more lectures, comes across as a string. That's because due to how form data is encoded, there's no typing. There's literally no concept of it. So that and arrays are a little difficult for, you might have to do some manual parsing on both of those. That's why we have to do things like parse int on everything. But you'll notice we do a parse int, everything works out just great. You'll also notice, let me go back to the calculator file. You'll also notice that in the calculator module, I also have to check if the type is number and if it is non. Now, is non means or is NaN means is not a number. Now, for some reason in JavaScript, it was determined that the concept of it's not a number should be of the same type of number. So that comes up as not a number, but still have a type of be equal to number. Just something you'll have to keep in mind when you're doing parse int, parse float, and so on and so forth. So if I were to do second number, you'll notice second number shows up as NaN. It's just a little quirk in JavaScript. So we have to, in all those, go through and check if there is not. Now, this is just a basic switch statement. The operation happens to be add. And if we were to have given an unsupported operation by, say, manually submitting the form, through some curl request, it would, give it like an operation of, I don't know, bake cookies, some other nonsense. It would just go and throw over here. Now you'll notice we surrounded this in a try catch. If we were using promises, we'd just .catch the promise and pick up the error message from that. And you'll notice that what we do is we catch the error, and then we just pass it back to the user. But you'll notice that we also pass down the first number, the second number, the operation, and the error. So, as you can see, in our server handlebars file, what we do is we pass all that model data right back in so that the user can just fill out whatever they were, fill out what they need to. You'll notice here, gets a value of NaN, which actually I should have done some basic checking for, and I should have said if this is non, then don't print it or set the value to be equal to undefined. And, so that's just a minor thing. It's only wiping it out because it's a type of number, and you're trying to set in the DOM a string to be a number, so it wipes that out. But what you'll notice is that we use this handlebar syntax to set the value, pass that data back in, and here we see if there's an error, print out an error. If there's a result, print out a result. Very basic server-side code. At this point, none of this should really be anything shocking or revolutionary. It's just basic Node at this point, and now basic HTML. However, if you have any questions, feel free to ask. So that's the case with how the server file works. The particular thing of interest, the particularly interesting point is that we do this server-side error checking now. Now, you can never trust user input. It's always going to be 50% bad on purpose, 49% bad on accident, and it's going to be 1% good just by chance when the user doesn't fill out something right. So you always have to do error checking, and the error checking you'll have to do for this class is you'll have to check that the inputs were actually given, the expected data was given. You'll have to check that they're of the proper type, and you'll have to check that they're of the proper bounds, and that at some points you may have to check if the user has access to the data that they're requesting, which you might need to do for your final projects depending on your project. So we always have to try, we can easily sanitize users' input sometimes. Like for example, even if we were submitting via JSON, we could also parse int on their request body number 1. That might, at times the user might accidentally submit a string and we can recover from that. But we can't recover from something like them trying to bake cookies rather than subtract the two numbers. So those are things where we just pass them back an error message. And so pretty standard stuff on that front. It's not very different from using an API. And you still have this abstracted data module thing. We could probably abstract it further and just do a try-catch around calculator.perform operation, but I wanted it to be a little more verbose than usual for the sake of this example. So, with that in mind, we also now have this concept of writing code that's accessible, writing JavaScript code for the front end. So let's take a quick look at something here. Let's close out that form.js. Let's close out everything but static, main, not app. Static, main, and public. All right. Where did main go? All right. So we've included finally our first JavaScript file of our own. If you see here, we have script source equals /public/js form.js. And that form.js goes into the public.js folder because of how the static assets were labeled up. Now, if you need to see that one more time, that is in app.use. Yeah, app.use public and static searches that static public directory for anything that matches the rest of the URL after public. So just pretty standard stuff. It says, okay, if a route to /public/js/form.js, go into this folder, go into that folder, check for form. It exists, so display it up to the user. So script files are included, and they are included and run in order, meaning jQuery, this will run first, followed by the Bootstrap JavaScript code, then this will be run. Now the browser might be smart enough to download these three at the same time, but it will always ensure that it runs this JavaScript file first, this JavaScript file second, this JavaScript file third. Very important. It's also very important that you keep these as the very last tags in your document, because while links to style sheets belong up top so that they can render while they can block the page, and then while the page renders they have style, you don't want this to be downloaded and run, because you want your page to be visible and so the user can start reading your content rather than block. Also, what if there was an error and you had an infinite loop somewhere? It would spin and spin and spin until the page crashes. At least in this case, it could spin and spin and spin, but the user can see your site before it crashes, not assume that their browser's broken. So with that in mind, what you should know is that in JavaScript, on the browser side, functional scope is, oh, there's a stray body tag. That's not good. Let's fix that up. That should have been caught. I'll commit that code and re-push it. What you should know is that when JavaScript code is run on the client side, there's a global scope that's also known as the window scope. So this global scope is populated by anything that's not defined inside another function. Now, that means that if I were to not be invoking this IIFE over here, all of these, well, this function, this element, these elements, this object would all be accessible in the global scope. Now that might not seem like such a bad thing until you realize, well, what if we had a function called, I don't know, getElement? And that's a native browser thing, is getElementById. So what if we named our function getElementById, meaning get something from an array based on the ID? We'd start overwriting document behaviors. We'd start writing things that are native to JavaScript. It's a browser API for all our modern browsers. So we try, as much as you can, run your client-side JavaScript inside of an immediately invoked function evaluation so that you can create a safe scope. Now this let call is fairly new and won't work on all browsers. If you're using certain versions of Internet Explorer, it will not work. But you can also just use var, especially if you're inside an IIFE. It's a little safer to use var. So I don't per se like using var, but I needed to demonstrate that the browsers are not as up to date in JavaScript as Node is. So take that as you will. So we see here that there's some basic DOM API usage here. We have this document.getElementById, which traverses our HTML document and finds the element with an ID of static-form. So we can do that again with all our inputs. Now we have essentially the same thing. And these are all DOM API accessible things. Now in Node we have access to file system calls, we have access to things like that, but in JavaScript in the browser we don't have access to file stuff. We don't have access to running multiple threads or anything. All we have access to, well, we do have access to a secondary thread through workers, but that is far beyond the scope of this course. Anyway, but we have access to the HTML document directly, and we can manipulate it in real time while the user's on it and interacting with it. So what we do is we can store references to HTML elements, add what's called event listeners, and manipulate them as we see fit. So here we have our first event listener for the submit action on the static form, which is all fine and dandy. The algorithm for this is basically to check if there's any, well, first hide the error container in the result container, try and perform things. If there's an error, show the error element. If there's a result, show the result element, and set the result set text about the result. So that's not so different from the Node code in that we have throwing, we have this method, we have this object that we're putting methods on, and so on. But what you'll notice is it's a little harder to organize because we have to have most related code in one functional scope. There's no real native dependency injection just yet in JavaScript, and we have a lot of DOM manipulation. Now we're very closely tied to the HTML and browser-based JavaScript. We're constantly attaching to JavaScript events to HTML nodes. We're listening for these DOM events. We're manipulating user data. We're parsing it. We're querying new data. We're displaying things. We're hiding things. That's what you do in JavaScript in the browser. It's useful for computation, but not so much because it has to do all the computation on the user's computer. So you really don't want to do anything heavy duty on it. That in mind, it's extremely useful. There's tons of useful things you can do to make a very interactive website through the use of this DOM API, which you'll be going through for the rest of the course. And browser-based JavaScript has many similarities to Node. You can view Node, though, as having just about everything that the browser has, except for the browser-specific concepts like the DOM API, but more. So that being said, that's a really brief introduction to a browser-based JavaScript, and if you look through this, it's very basic error checking. As you can see, I can do 0, 0, submit it, leave it blank, must provide a number, it's the same stuff. But it doesn't refresh the page. This result is rendered on the page because it's using client-side JavaScript to run our calculator. So that's a calculator two different ways. I hope that helps you understand front-end versus back-end JavaScript and forms a little easier. Have a great night.